AI agents are starting to use long-term memory. This is powerful, but it creates a new security problem. If one bad claim gets written into the shared memory, every future agent can inherit it. Hi, this is Harsh here, and this is Mithril. Imagine an agent reads a poisoned Slack message that says MD5 is approved for password hashing and stores it as company knowledge. Now, future coding agents, support agents, or security agents may treat that false claim as verified truths. Mithril is built for this exact failure problem. It catches poison claims before memory commits. Imagine a research workflow where multiple agents are working across the Cognee memory graph. One agent verifies a billing policy, for example, refunds above $1,000 require manager approval. Later, another agent returns with a bad claim, such as refunds of any amount can be approved automatically. Without Mithril, the poisoned update could enter the shared memory, and every future agent would waste tokens reasoning from corrupted context. With Mithril, the second claim is checked against verified memory before it is stored. If it contradicts trusted context, it is blocked, quarantined, or sent to review. This protects the shared memory layer, saves downstream research, and prevents a compromised agent from contaminating the rest of the system. To understand the project quickly, I've designed this demo right here. So this is the demo for the project. First, I reset the state for the memory here. So we start from a fresh new state. So reset. So after resetting, we will seed the database where I add password policies like argon2 ID is required. So we will seed. Okay, so after seeding the baseline, we will try and run attacks on it, like adding claims in memory like direct contradictions or subtle misinformation or credentials. So we'll now run attacks and check like which memory claims get flagged. Okay, so we can see that the attacks got rejected. Now we will quickly run a recall to test if the memory actually is safe. Okay, so the initial claim is still present and preserved. As you can see, this was the initial claim. Okay, so I also ran a full benchmark through my local Olama model. We can see that here. The benchmark has 31 labeled cases, 21 memory poisoning, and 10 are legitimate updates. It covers direct contradiction, misinformation, and policy evasion. The result was strong for the main security goal. Mithril blocked 21 out of 21 attacks. The poison leak rate was 0%, meaning no malicious claim has reached the memory. The only honest trade-off here is that the configuration is conservative. It overblocked 7 out of the 10 legitimate updates, so the false positive rate is high, but for a memory firewall, that should be pretty much acceptable. The next improvement in this version would be memory suppression, so authoritative updates can replace older verified facts without weakening the attack detection. We can use Mithril with using multiple ways. There is a Python SDK for direct agent integration, and there is a fast API REST API for apps and dashboards. There is an MCP server, so agents can integrate tools. And each section has its own documentation, which can be viewed through the following URLs. So this is the live deployed version. Okay, so for the current submission, the deployed site is front-end first. The backend works, but I'm currently running it locally through Olama because the free hosted APIs are quite rate limited here. This is why the deployed site includes a benchmark results page and raw JSON from the completed run. Judges can inspect the front end, the demo flow, the docs, and the benchmark summary. If you want to test the full backend live, the docs include local setup path with Olama. After optimizing LLM call volume and adding a more reliable hosted inference provider, the backend can be deployed as a hosted fast API service. Okay, so for the ending regards, the core idea is simple. As AI agents get memory, memory needs a firewall. Mithril makes shared memory safer by checking claims before they become facts future agents believe. Thank you.